SwayamPrabha. Digital India. Educated India.
Hello, welcome to the next lecture. This is going to be a continuation of the previous lecture where we were discussing how to idealize a slanted cross section, a cross section with certain slanted portion. So, let us continue from where we have left. In the last lecture, we have just encircled a small slanted portion, enlarged and had drawn the stress distribution or distribution of the normal stress in that portion, and if we idealize those portion by two booms B1 and B2 and have the same stress sigma 1 and sigma 2 at boom 1 and 2, then we need to find out what would be B1 and what would be the area B2. Now, to find this out, let us take moment about point 2. So, if we take moment about point 2 from the actual cross section or from the left hand side figure, we get that the moment about 2 is going to be sigma 2 into T into B into B by 2. So, I am actually dividing this slanted thing into a rectangular distribution plus a triangular distribution. So, I am sorry, I have made a small mistake here. So, this is going to be sigma 1 and this is sigma 2. Now, the moment because of the rectangular portion is going to be sigma 2 into Tb. So, this is the force, total force, which is sigma 2 into Tb. So, and that I am, and the momentum about point 2 is just going to be B by 2. So, this is one part of it. Now, let us take for the rectangular, for the triangular cross section. For the triangular cross section, I will have half sigma 1 minus sigma 2 into T into B. This is the force, this is the total force part, and that is going to have a momentum of 2 B by 3 about the point 2. So, that is what we are going to have. So, so let me just write into 2 B by 3 is going to be the momentum. So, this left hand side is coming from the actual portion of the cross section, portion of the actual cross section. Now, in order to maintain the same distribution of stress, this moment has to be equal to the moment produced in the skin stranger idealized cross section about point 2. Now, if I try to find that out, that is going to be sigma 1 into, that is going to be B1, that is area of boom 1. This is giving me the total force and that into the moment arm, which is going to be B. So, therefore, this is coming from the portion of the approximated or idealized cross section. Now, this two needs to be equated. So, let us try to simplify this. Let me just cancel out b from either side. Therefore, I will have sigma 2 by 2 plus sigma 1 minus sigma 2 by 3 into Tb is going to be sigma 1 into B1. Now, if I now try to find out B1, it is going to be sigma 2 by sigma 1 by 2 plus 1 sigma 1 by this is going to be 1/3 plus 1/3 minus sigma 2 by sigma 1 by 3 into T into P. This is what I am going to get. Now, if I simplify this, this is going to be B1 is going to be equal to T into B into 1/3 plus 6 into 3 minus 2 1 by 6 sigma 2 by sigma 1. Therefore, B1 can actually be written as Tb by 6 2 plus sigma 2 by sigma 1. So, this is the expression for B1 that I have got in terms of my known parameter. Now, what would be sigma 2 by sigma 1? Sigma 2 by sigma 1 can indirectly written as y2, which is the distance from the centroidal axis, and y1, which is the distance from the centroidal axis again. Okay. So, therefore, if we know the position of 1 about the centroidal x axis and the position of 2 about the centroidal x axis and the thickness and the length of that portion, we can find out B1. Let us investigate this further. Therefore, we have got B1, therefore, we have got B1 to be Bt by 6 2 plus sigma 2 by sigma 1. Bt is nothing but the area A by 6 into 2 plus sigma 2 by sigma 1. Now, let us assume that let us assume a case where the portion is horizontal. Just for the sake of checking, the portion is horizontal. Then what do we get? If the portion is horizontal, then sigma 2 is going to be equal to sigma 1. If that is the case, then B1 is going to be A by 6 2 plus 1, and that is going to be A by 2. So, this gives us exactly the 1/2 rule for the horizontal portion. Now, let us see if the portion is vertical. If the portion is vertical, then I know that sigma 2 is going to be minus sigma 1, which is going to imply that B1 is going to be A by 6 2 minus 1. So, which is going to give us a by 6. So, this is going to be the 1/6 rule of the vertical wave. So, we can see that we get the half rule as well as we get the 1/6 rule from this single expression that we have derived. Therefore, we can use this equation, let us call it as equation 1, for a horizontal portion, for a vertical portion, as well as for a portion which is inclined or slanted. So, if we use the same logic, we can find out B2 as well. So, the B2 by using the same way that we have derived is going to be TB by 6 to this one will just be the numerator and the denominator will just be swapped. So, B1 is TB by 6 2 plus sigma 2 by sigma 1, and B2 is just going to be the ratio of sigma 2 and sigma 1 will just be flipped. So, this let us call that equation 1, and let us use this equation to solve a problem, an example problem. So, let us see this example problem. So, this example problem is of a slanted cross section with slanted portion. So, the thickness, I will use red color to write down the thickness. So, thickness is given by the red color. So, let me write down the thickness. The thickness of this portion is 2 mm. The thickness of this portion is 1.5 mm. I'll skip the mm part. I mentioned that all dimensions are. So, this thickness is 3 mm. This thickness is 2.5 mm, and this thickness is 2 mm. Let us put number for all the points. This is 1, this is 2, and this is 3. This is 4, this is 5, this is 6. I have drawn the stringers as well. Area of all stringers are same, or the area of all the stringers is equal, and that is equal to, so area of each stringer is given as 300 millimeter square, and all the dimensions are in millimeter. So, this is the x axis, this will be the y axis. So, the second point is that the cross section is symmetric. I unfortunately didn't do the x axis to be symmetric. The x axis, the cross section is symmetric. So, the first point is this. The second point is that the cross section is symmetric about x axis. Now, we have to do a skin stranger idealization of this cross section given. So, for skin stranger idealization, let me draw the skin stranger idealized cross section. So, we as commonly done, as has been discussed in detail earlier, we will place booms wherever there are stringers. So, let me place booms wherever there are stringers. So, let me call this as boom area of boom 1 is boom 1, this is B2 and this is B3, this is B4, B5 and B6. Now, B1 of course is going to be equal to B6 because they will be symmetric. B2 is going to be equal to B5 and B3 is going to be equal to B4, and this is due to symmetry about x axis. Now, our job is to find the areas. So, find B1, B2 and B3. So, this is the job that we have in hand. So, so this again let me write down, this is the skin stranger idealized cross section. Now, if this is the cross section, so our job is to now find out B1, B2, B3. So, let us first start with B1. So, if I try to find out B1, B1 is going to be the area of the stranger at 1. Plus portion of the vertical web (1, 2) plus portion of 1, 6. Now, let me, if I replace everything, area of the stranger is 300 plus portion of 1, 2. Portion of 1, 2 is going to be, the length is 600, the thickness is 2 divided by 6, 2 plus sigma 2 by sigma 1. Now, sigma 2 by sigma 1, and for the portion 1/6, for the portion 1/6, we can write this, the length is 400, the thickness is 3 by 6 into so the area is, length is 400, the thickness is 3 by 6 into 2 plus sigma 6 by sigma 1. So, that is going to be 300 plus 200 into 2 plus sigma 2 by sigma 1 would be y2 by y1. So, that is going to be 3 by 4. And the portion 1/6, since it is vertical, we do not even need to do this, and we can simply write down the 1/6 rule. So, this is going to be minus 1. So, 1/6 rule, that is 1/6 into 400 into 3. So, therefore, we get 300 plus 200 into 2.75 plus 200. If we calculate this, this is going to be 1050 millimeter square. So, we have found out the area of B1, which is also going to be the area of B6. So, the first part of the problem is done. Now, let us try to find out B2. So, if we try to find B2, the area of B2 is going to be 2 into, there are two stringers, to 2 into 300 plus we will have two stringers, two slanted portion here. For portion 1, 2, so we will have 600 into the thickness is 2 by 6, 2 plus sigma 1 by sigma 2. Okay. So, this is because of portion 1, 2. This is because of 1, 2. Then we are going to have plus 600 into 1.5 by 6, 2 plus sigma 3 by sigma 2. This is going to be for the portion 2, 3. Now, the portion 2, 5 is just the vertical web. So, that can be written as 300 into 2.5 by 6, just by using the 1/6 rule. So, therefore, this can rather be written as B2 is going to be 600 plus 200 to sigma 1 is going to be 4 by 3 plus 150 into 2 by 3 plus 50 into 2.5. So, if we calculate this, this is going to turn out to be 1791.67. So, that is going to be B2 and that is going to be B5. So, we have figured out the area of boom 2 and boom 5. Now, let us try to find out the area B3 or B4. So, let me just erase this off. And let me find out B3. Now, B3 has only one stringer at that point. So, it is going to be area of stringer at 3 plus portion of area of 2, 3 plus portion of area of 3, 4. Now, if I substitute these values, this is going to be 300 this is going to be 600 into 1.5, the thickness being 1.5 by 6 2 plus sigma 2 by sigma 3. And the 3/4 portion is just a vertical web. So, we can just call it as 1/6 into 200 and the thickness is 2. So, we have this area. So, we can write this as 300 plus 150, 2 plus sigma 2 by sigma 3, which is going to be 3 by 2 plus 400 by 6. If we evaluate this, this is going to be 891. So, that is going to be 891.7 millimeter square. So, that is going to be B3 and that is equal to B4. Therefore, we have find out B3, B4 also. So, therefore, we have found out area of all the stringer B1, B2 and B3. So, in the next lecture, we will discuss how to find out the shear flow due to shear forces in a skin stringer idealized beam. Thank you.